Hello, my amazing students. This is Mrs. A, and I love math. And look at the beautiful picture I drew for you. I'm such an artist. Not. But look what it says up here. 50 lessons left. That's all. We have 137 lessons in our book. And the last lesson I taught you was lesson 87. We have only 50 lessons left to finish the school year. I think that's worth a little yippee, don't you? Yay! We have only 50 lessons left. I thought that was pretty cool. So, we're going to be doing lesson 88 today. And lesson 88 is formats for equations and how do we deal with negative coefficients. Okay, so the first thing that we're going to do is talk about the addition rule for equations. The same quantity can be added to both sides of an equation without changing the solution of the equation. Now this is very important. When we add the same thing to both sides, then that's what the addition rule is talking about. What happens if we really needed to subtract the same thing from both sides? Well, addition and subtraction are both inverse operations, right? So I can express any subtraction problem as addition of the opposite. So I can add a negative number to both sides, and it's the same thing as subtracting. So let's see how this rule works. So the first one I'm going to show you is, whoops, I'm moving there we go. All right, so here's our first problem. X plus 2 is 6. Now, in the past, we have done this problem by writing X plus 2, leaving a little space. There's my 6. And then to undo the 2, we would minus the 2 and minus the 2 on the other side. And that works. Well, we would have X, 2 minus 2 goes away, so we'd have X equals 6 minus 2, which is 4. And that is completely correct. No problem with that. But now, in this lesson, they want to show us a couple of different things to think about. As we're getting into algebra, we're moving away from arithmetic, and there's just some little formats that we find a little bit easier in algebra. So, what if instead of minusing 2, we instead left the problem just like it is, and we added a negative 2 to both sides. And we didn't do it horizontally like we just did, but we do it vertically. What if we said, okay, I need to get rid of the 2. So I'm going to add a negative 2, and I'm going to add over here the same thing that I added. I have to add the same thing to both sides. So 2 plus a negative 2 goes away. It's the same thing as minus 2, isn't it? So we end up with X. This cancels out. And then over here, we have 6 plus a negative 2 is 4. We have the same answer. But the addition is vertical. And very often, it's easier for us to do this as we're working more complicated problems. Okay, so here we have X plus 5 is 7. We need to get rid of the 5 to get the X by itself. So we're going to plus a minus 5 plus a minus 5. Okay, and so the 5 and the plus a minus 5 is going to go out. And we have only the X left. 7 plus a negative 5 is just 2. Okay, now because plus a minus 5 is the same thing as minus 5. That adding can kind of get a little redundant. So it's not a big deal if instead of plus a minus 5, we just put minus 5 minus 5. That's okay too. Because addition is, the addition rule can apply to both addition and subtraction because subtraction is simply addition of the opposite. So we don't have to get all hung up about it. So we really could skip the parenthesis and skip the plus sign and just -5 and -5. And it's the same thing. So don't get hung up about it. Okay? Now the problems are starting to look a bit more fun. Okay, so on this one, we have a problem that has fractions in it. So we want to get rid of the 1/2. So what if we subtract the 1/2 or add a -1/2, either way, and subtract a 1/2 over here? Okay, now what's going to happen is I get a 2x on the left. This cancels out, makes it a little bit easier. But now I've got a 3/4 minus a 1/2. What do I always have to do when I have fractions? Before I can add or subtract them, don't I have to get a common denominator? So instead of doing this in one step, what if I say 3/4 minus, could I change 1/2 multiplied by 2 on the top and the bottom to 2/4? I could, couldn't I? So now what do I have? 2x equals 3/4 minus 2/4 is 1/4. Whew. Well, that's a little bit better. But now I need x, not 2x. So could I divide both sides by 2? Okay, but dividing by 2, sometimes it's easier, instead of divide by 2, to multiply by 1/2. And dividing by 2 and multiplying by 1/2 are the same thing, aren't they? Okay, so division is multiplication by a reciprocal. So we're going to multiply by 1/2 to get rid of the 2, and we're going to multiply by 1/2 over here to get rid of the 2. I mean, to do the same thing to both sides. So now 2/1 times 1/2, those cancel out. We're left with x equals 1/8. Okay, x equals 1/8. So now you're going to be able to do more complicated problems because you know how to handle your equations. Okay, so now we're going to move into the next part of the lesson, which is what happens when we're multiplying by a -2. So we have a coefficient. Coefficients happen in front of a variable, so it's the number that's the variable's multiplied, and it's negative. We could do this two ways. We're going to do it both ways. We could divide both sides by -2. That's perfectly okay. And a negative divided by negative, -2 divided by -2 is just 1. So we end up with a 1x or an x equals. Now we have a positive divided by a negative gives me a -2. So the answer is -2. All right, so that's one way to do it. The other way your book suggests you to do it is to start back right here. And since you're going to have to divide by a -2 to make it a little bit easier, they said, well, why mess with it? Why don't you, just at the very beginning of the problem, multiply everything by a -1? If we multiply this side by a -1, then all of a sudden we have a +2. We multiply this side by a -1, we have a -4. So now when we divide by a number, we're dividing by a 2 instead of a -2. So we're going to get divide by 2, divide by 2, and we're going to get 2 divided by 2 is still 1, and -4 divided by 2 is -2. So what the author is doing is the author says a lot of times people have an easier time dividing by a positive number than a negative number. So why fight it? Why not just change your signs by multiplying by a -1? Then you don't have to worry about it. So we get the same answer both ways. So here, let's do this one. We have a -3x. So let's do it both ways. So we're going to just divide by a -3 and divide by a -3. That's perfectly valid. These cancel and we're left with x equals positive divided by a negative is a -4. If you don't have any problem with that, you just do it that way as much as you want to. No big deal. But if -3x equals 12 gives you troubles, Start by multiplying both sides by -1. So negative 3x times -1 becomes 3x, and 12 times a -1 becomes a -12. So now when we're getting rid of the 3, we just divide by a 3 instead of by a -3. And guess what? We get the same answer. The 3's cancel. X is -4. We get the same answer, but some people find it easier to do it when you don't divide by the negative number. You pick which method is easiest for you. So here we come back with a few more problems. Okay, so here's our last example, and then you have 2 practice problems to work on. All right, so whenever we're solving an equation, the very first thing we want to do is get the variable term by itself. Here's the variable term. So the very thing we want to do first is get rid of the 4. So let's subtract a 4 or add a -4 to both sides of the equal sign. So now we have -3x. The 4's and the -4 cancels. 10 plus a -4 is a 6. So our equation is simpler, okay? So now we could divide both sides by -3. That would work out just fine. And we would get 1x, or x, equals positive divided by a negative is a -2. Okay? If that method bothers you, then instead of dividing by a -3, we would get back here, -3x is a positive 6. And we'd say, I really don't want to mess with dividing by a negative number. So I'm going to change both signs by multiplying through by a -1. No big deal. So then we divide by a +3, divide by a +3. We still get x is -2. So that's just another method of doing it. So now we're going to do your practice problems. Okay, so here's your first practice problem. I want you to copy it down and pause your video. Hopefully you paused your video. Remember, the very first thing we're going to do is get this variable term by itself, which means we need to get rid of the 5. So we're going to add a -5 to both sides of the equation, sign, the equal sign, and then we're going to bring this down, -2x. We're going to cancel this, and we're going to say 9 minus 5 is 4. So it is much simpler, isn't it? So now we have a -2x. If you want to, multiply both sides by a -1 to get rid of the -2. If it doesn't bother you, then just divide by -2 on both sides. Get rid of the -2's cancel. And we're left with x is 4 divided by -2, positive divided by negative, opposite sign. So we're going to get a -2. Now, we haven't done this, but let's check it. Let's take the -2 and run it right back up there and substitute it in where the x was. -2 times -2 is positive 4. 4 plus 5 is 9, and it works. Okay, so every once in a while you might want to check your problems and make sure you're getting them right. Okay, we have one more practice problem. Here's our last problem, so copy it down and pause your video. Hopefully you did that. Now here is our variable term. We want to get our variable term by itself on one side of the equation. That means we have to get rid of the 1/2. So since it's a positive 1/2, we're going to subtract a 1/2 or add a -1/2 and do the same thing to the other side. So now that I have a little bit more room on the board, we're going to draw a line. We're going to bring this down, -3x. This is going to cancel because they're the same but opposites. Now, I have room over here to change my 1/2 to 8ths. It's a -1/2. And I'm going to multiply the top and the bottom by 4. Okay, so -1 times 4 is -4. And 2 times 4 is 8. So I've got a negative 4/8, which is the same thing as a negative 1/2. So 3/8 plus a negative 4/8. Opposite signs. I really subtract, don't I? So 3 plus a negative 4 is a negative 1/8. Okay, so now, almost there, I'm going to have to divide by a negative 3. Now, since I have a negative on both sides, can't I just get rid of them? Can't I just say, oh, multiply that by negative 1 and multiply that by negative 1? So now I've got 3x is 1/8. And so now I'm going to divide by 3. And dividing by 3 is the same thing as multiplying by 1/3. Since we have fractions, it's usually easier to multiply by 1/3. So here's my 3x over 1. We're going to multiply by 1 over 3. And over here, we're going to multiply by 1 over 3. When we have fractions, it's usually easier to use 1/3 instead of dividing by 3. We multiply by 1/3. So you can see that the 3 and the 3 cancel, and the 1 and the 1, of course, cancel, and we're left with x. So we have x equals 1/8 plus 1/3 is 1 over 24. Now, do we dare check it? Let's check it. Okay, so we're going to put right here, I'm going to erase the x, and I'm going to put 1 over 24 right where the x was. So now, let's get a different color and see if our answer is correct. So I have negative 3 over 24. And the 3 and the 24 will cancel and give me negative 1/8. All right? So I have here negative 1/8. And then I'm going to add 1/2. But 1/2 is the same as 4/8. So 4/8 and negative 1/8 plus 4/8. It is 3/8, isn't it? And we got it right. That is your last problem. Now we're going to be doing a lot more with equations, so you need to practice, practice, practice. We are done with lesson 88. So now we only have 49 more lessons in our book. We're getting down there, aren't we? This is Mrs. A, and may God bless your day.